Hello everyone, welcome to Learn Overflow. In this video, we will look into how we can solve this question, today's LeetCode question, that is the count vowels permutation. This is a hard type question, and we will look from going through the brute force way of solving this and then trying to optimize our code to as much as possible. We will look into all of those, but before moving on, make sure to subscribe to this channel if you haven't already for regular LeetCode videos like this. So let's start with this. So it says like we are given an integer n, so that's the integer n given to our function, and our task is to count how many strings of length n can be formed using this rules we have over here. Fine. So how many string we can form is the main task. Okay, how many string of length n? That's the task. Okay, fine. Now there are rules given to us. Fine. Let's see what are these rules are. These rules are basically the first thing they say are each character is a lowercase vowel. So lowercase vowels as A, E, I, O, U are the 5 vowels we have. So this is important for us. Like there is only 5. So this helps us in our complexity. Okay. Like the time complexity, space complexity calculation. This will be helpful for us. So it says like the 5 is the lowercase English, lowercase vowels are there only. Fine. Now it further says like each vowel is A. Like whenever the vowel is A, it should follow by E. Fine. Like may only follow by E. Fine. So whenever there's an A, if we need to go ahead with the next character, after an A, we should go ahead with only an E. Fine. That's what it says. Further, it mentions that if it's an E, then it should be followed by A or an I. Fine. Further, it says like if it's an I, then it should be followed. It should not be followed by another I. So what that does mean? That means like all the 5 of this can be there without the I. So like all the 4 of them can be followed by an I. Like after an I, all these 4 can be sitting. Okay. So that's what it means by that. And next is this, if it's O, then it should be followed by I or U. Okay. If it's an O, then followed by I and U. And then if it's an U, then it should be followed by U. Like if it's an U, then it should be followed by an A. So that's the idea. So let's see what the basic brute force way of what is it telling us to do. So first of all, say we don't have any length, right? There's 0 length. Now after that, if we look ahead to length of 1, then what can be the thing? There can be 5 ways. What are the 5 ways? The 5 ways being A, E, I, O, and U. Fine. So A, E, I, O, U are the 5 letters. So like whenever N is 1, our answer is 5. That means this is the 5 length like this of length 1 string, like 5 strings are possible of length 1. Okay. Now if we want to go with N equals to 2, fine. What can it be? After A, look, after A, what can it follow? A may be followed by an E. So after A, the next character of A will be an E. Fine. So that's what it mentions, that after A, it should only be an E. So we cannot go ahead with any other character. We can go ahead with only a single character, that is an E. Fine. Further, it mentioned after E, it should only be A and I. So after E, it should only be an A or an I. Fine. That's the 2 thing it mentions to us. Fine. So then after I, it may not be an I. So if it's not an I, then there is like 4 options to us, right? Now after O, what will be our next character? O is followed by I or U. So O is followed, like after O, there can be 2 characters possible. Any two of the 2 is like I or U. I or U. Fine. Then after U, U can be followed by an A. Fine. After U, it can only be an A. Now look carefully. What are the then how many answer are we getting? We are getting like 3 plus 4 plus 3. So that is a 10. So look, whenever 2 N is 2, we are getting an answer as 2. So this is like we are going ahead with we are adding a single character at the end based on the following rules, and we are finding out that this will be our answer. But this may not be the best way to solve this question. Why I'm telling you? Look, if it's given like if n is something like more than this, say n can be 2 into 10 to the power 4, right? That's what n can be, n into 2 into 10 to the power 4. So if n is 2 into 10 to the power 4, then is it possible, is it like, is it even a feasible way to go ahead with calculating one by one in this way and ultimately finding a solution? I don't think that's yes, because this will keep on like the this particular graph, or this particular tree will keep on increasing whenever we find an I. See, there's like two I are there. Okay, in this, after the second n equals 2, we find that there can be two I. Right, for each I we are getting four outputs, like we are getting four paths to go ahead with. So it's not even a feasible way or a possible way to go ahead with. Fine, so we need to think of something to optimize it. Look carefully. We are here with we are doing it in what manner? We are saying that what is the last character? Last character is A, and we are going, it's the next character is E. Fine, like after A it should be an E. That's the next character. But if we look at it in a different way, that if it's A, okay, then what are the characters that may come after an A? Like let's stabilize this. Say uh, see, what do I exactly mean is like, say n is one, then how many strings can be possible of like uh, after, like at a, like with a, how many, like if the ending character is a, like if our character is a, then how many is possible? So in the like ending or the previous forward is not possible, like is not considered one. So like there can be only one way these strings can be set. Okay, but next one, when n is 2, fine, when n is 2, then how many strings are there ending with a? Like if we look, it's like 1, it's like 2, and it's like 3. So our answer is 3. Fine. So in this way, we will go ahead and calculate it in our normal way. But can we do anything to just memorize it or keep a track of the letters? Okay. So in that case, we are looking at which are the letters that are ending with a. But if we look in a different way, like what are the previous letters that may lead to our A? Look here, what I mean. We are looking at after A, there can be only an E. Fine. But if you look at it in a different way, like E can be a answer to which of these letters? Like in the reverse way, we are looking like what can the previous letters to? Yeah, like let's take A. So what can the previous letters to A? Like what can be the previous letters or the previous steps where other letters are there that may lead to our particular A. Okay, look, what can be there? So if it's an E, fine. If it's an E, that may lead to our A. That's condition one. Fine. If it's an I, can it lead to A? I is said like it cannot lead to I. So other than I, it can lead to everything. So yes, it can lead to an A, right? I can lead to an A. Then if it's an O, can it lead to an A? No, it can lead to an only I and U. Fine. If it's an U, can it lead to an A? Yes, it can lead to an A. Like if it's an U, like we are looking for what is the last character. If the last step, in our last step, the value is an U, then it can lead to exactly A. So now how we can go ahead with that for our particular calculation? We know that A, I, and like E, I, and U can only lead to an A. Fine. So what do we need to check? We need to check like in the last step that whatever n we are at n equal to 2. So in the last step that is n equal to 1, how many values are ending with these three letters? So there's like E is ending with E is only one, ending with I is only one, and ending with U is only one. So our answer is like the sum of all these three. Okay, all these three values. Whatever is 1 plus 1 is like 3 is the value, so we get a value of 3. Let's look differently to the other values. What we have exactly? Fine. So let's look exactly for a value like E. Fine, for a value like E, what are the other values of value like E? We can see that see what are the values that are ending with E. Like E can be possible after an A, E is possible. Fine, after an A, E is a possible value. Fine. And then after the E, can it be a E? No. After an I, can it be a E? Yes, it's a E. E is possible over here. So A and I, I'm sorry. yeah, A and I are possible over here, fine. Then after O, can it be an E possible? No. After an U, can it be a E possible? No. So what are the two values that can lead to an E? E and I. Fine. So if, when you are looking forward to an E, then we need to check like what are the previous value of A and I. Fine. A is what? A is 1 and I is 1. So sum of this two is like 2. So that's our current value of E. Look, what is the current value in our step 2? E is over here and E is over here, and we know it's a value of like there are two values only there, right? That are ending with E. So we are not looking, the question is asking us to look for the next relation. Like after A, there can be an E. So that's the question is asking us to say. But we are rather looking at in the format like before E, what are the possible areas that can lead to an E? That is an A and an I. So that's what we are looking forward. And we are directly calculating the sum of the previous values, like previous n of a and e, or a and I of for calculating a value of e. So what exactly be the formulation? We cannot calculate it one by one looking at the graph. So we need to come up with some formulation. So what exactly will be the formulation for it? The formulation will be, look, the formulation is exactly like if you look, if you take it as a dp or something like that, whatever be the current, like the current value of n, okay, let me write it for you. So the dp of e, that is the we are finding two. Two means the current value of the current value we are looking at. So that's n, and we should look at a dp of one, that is n minus one. Okay. So let's generalize it later. Let's see what we are doing. We are doing dp of two e, that is this current value, is basically dp of one a. That is at the previous value of a, well, how many a are there, plus dp of 1i, the previous value of I, how many ones are there in the previous step. Okay, so that leads us to the next case, that is the current value of each step. So the similar way we will go ahead with dp of 2i, dp of 2a, dp of 2o, dp of 2u. Similar way we'll keep on traversing. So this 2 is basically our n, and this I, that is this 1, is basically our n minus 1. Fine. And this a, e, and I, we know there are like 5 values only possible. Fine. So a, e, and I, like a, e, I, o, u are like the 5 values we have over here. Fine. So we can directly go ahead with those values to store our values. Fine. So that's the weight in that. Now, what will be a complexity? See, like for this time complexity, we are going ahead with we are going ahead with this 5 values, right? There will be like 5, like this particular step is taking order of 1. Fine. What we are doing, we're just adding something. Fine. Order of 1. Now this order of 1 is like repeated 5 times, right? For this 5 alphabets we have, 5 vowels we have, so that is order of 5. Fine. But this order of 5 is repeated how many times? This order of 5 is basically a constant time, but this is repeated how many times? This is repeated exactly number of times this n is there. So n is can be any value, right? N can be any value. So that basically brings us to order of n, because there is 5n, but 5 is constant. So order of n is the particular value we are going ahead with. Fine. So we will be looking for that complexity. Now, if we talk about the space complexity is, again, look, there are like 5 spaces are needed. 5 spaces are needed, but it's like 5 multiplied by how many times the n is needed, right? How many times the n is needed is like, if n is 3, we need 5 into 3, that is 15 spaces are needed, right? But that's more or less like order of 5n, right? Like there's the time is it is going to take for us, fine. But can we reduce this? Can we reduce the space complexity? I mean, how? Look, we can use basically two arrays, not an 2D DP array, but rather a 2 array. How? One is a previous, that is storing a previous value, that is n minus 1. See, we don't need all the values. If we are calculating dp of, say we are calculating dp of 100 and then say a, do we really need the value of dp of 1, dp of 1, or dp of 2? Are those values needed to calculate that? No, we only need dp of 99 to calculate the value of dp of 100. Fine. So in that case, we will store the previous value as a previous array of or length 5, simply a 1d array of length 5, and our next array as like dp of our current DP array that is storing our current value. So once we'll move ahead with each step, we'll simply say the previous to be our current DP and our DP will be the next value that we will calculate. Fine. So that will be the whole idea. So in that case, we'll use only order of 5, like this 5 and the next 5. That is the 10 spaces are needed, right? Exact constant spaces are needed for that. So without doing this a whole 2D array, we can actually reduce this to 1D array, 1D array, and continue with our steps. So that will be the whole idea. Now, if we keep on traversing that for n number of steps, we are still there with two array spaces. Find two array spaces, I mean exact 10 array spaces. We are not incrementing our array spaces, we are just going ahead with that. We are no way interested in finding further spaces, we are just going ahead with that. Okay, so that's the whole idea. Okay, so now we got a whole idea. So let's go ahead and write this code, and we'll find out how easily we can do this. Exactly. Fine. Wow. So this is how it works actually for us. Fine. Now let's see what exactly we did. We did more or less exactly what we were discussing in the whole time. Okay. So first of all, we took like 5 integer variables like a, e, I, o, u, and we marked them as 0, 1, 2, 3, and 4. Fine, for like better visibility of our whole code. Fine. Then we took this mod being the value. This is what we are asked to return. Fine, return this as a module of 10 to the power 9 plus 7. So that's the whole thing. Then we took our two arrays, 1D array, look carefully, there's a 1D array, long, we took as long value, and it's of length 5. 5 is like this is the current DP, this is the previous DP that will store as the previous values. Fine. Now, then we did arrays dot fill, 1L. So 1L is like whenever you are filling something with long values, you make it as, you write a capital L as the end. Fine. So that's the 1L. Now, in this one, like after filling this one, why we are doing this? We are basically doing this step for the first calculation when n is 1. Okay, if whenever n is 1, there's no need to go ahead with further calculations. Fine. So we are simply did n is 1. So we filled all the previous values as 1, 1, 1, 1, 1. So it's like if we sum all those, that will be a 5. So in the next step, we'll understand that this n minus minus greater than 1. So we just doing this while loop till n is greater than 1. Fine. If n is less than 1, we are least interested in working out with it. Fine. Or less than or equal to 1, that is like equal to 1, we don't want to do it. So if it is equal to 1, this it will not enter into this loop. Then what it will do, it will simply do summation of all the previous a, previous e, previous I, o, and u, summation all this and data modulo, and returned it as an integer. Fine. Since we are taking it as a log type like array, so we just returned it as an integer. Fine. So that was the whole idea. Now, what exactly we did within our while loop, that is from n equal to 2 till n equal to the maximum value of n that can be possible, that is the 2 into 10 to the power 4. For this large values, what we are doing exactly, we're taking the current value of dp of a, e, I, o, u. Right. So this is the current dp, and this is equal to, for a is like previous of e, I, and u. I showed you exactly that those are the values give can be possible. Fine. And then it's like if we just look forward, it's like e is like a and I, summation of a and I. So for e, okay, e can be possible in e is at a, and e can be possible at I, right? I is except I, so then that's where e is possible. So similar way, I is possible at e and o. I is possible at e and o, that is after e, I is a possible value, and after o, I is a possible value. Fine. So that's way. And for o is getting possible only after I. O cannot be possible from any other value. O can be possible only after I. Fine. Similarly, u is like after I and o. Fine. U is possible at I, that is at this position or this position. There you can see u is possible. So that was the whole idea, and then we just kept on traversing. We just moved our DP array to be our previous DP, and our previous DP is storing our this current DP. So we are just reusing the spaces again and again. Okay, we're just swiping the spaces just to reuse it again and again. Fine. That's the whole thing, and ultimately we just return the summation of all the previous values at this current position. So at this current position, well, that means we are already at the current position. So whatever the values, we just returned it. Okay, so that's the whole idea, and that's how this whole question works. Okay, so I hope I can make you understand how this question works and how easily you can think of solving a questions like this. Okay, so make sure to subscribe to this channel for regular LeetCode videos like this. Also, like this video if you think this video is worth it to make you understand this concept, and also comment down if you have any doubts or questions related to this question. I'll be happy to help you out in the comment section as well. Thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.